Here we're talking about multiplying complex numbers. Here is the code. Our lesson is 1.3.3. That's what you're looking for on my YouTube station. You can subscribe.
Like and subscribe.
I'll do another one later, okay? All right, here's the deal to this. Bring it back, bring it back. This is exactly the same as FOIL or the box method, which we did in the warm-up, okay? The same rules are going to apply if I'm dealing with an expression with a variable and a number, or if I'm dealing with a complex number which has the real and the imaginary part. Same rules apply. Don't be intimidated. Just because we have to apply this with complex numbers, it's no big deal. As long as we follow our rules, so you could do the rules where you do FOIL, first, outer, inner, last, or let's try the box method because that's something new and it's been helpful. Especially when we're dealing down here with complex, the box is specifically helpful. All right, let's go ahead and do this. X times x is x squared. 5 plus or times x is positive 5x. 5 times positive 3, positive 3x. 5 times 3, positive 15. The box method allows me to organize, get all my terms. I want all these terms now rewritten so that I can combine like terms. You see, we're doing. We're really focusing on also bringing out all the signs to make sure that we get those in order. So I know it's just x squared, but I put it there just in case it was a minus. Okay, it's a negative. What can we combine here?
3x.
There we go. These are some common terms here, like terms x squared plus 8x plus 15. And that would be my answer. We did that in the warm-up. I think we're pretty solid on that. Remember, we did that last Wednesday. That was one key part of the last quiz. So now if I just have to apply this to a complex number, right? I have a binomial still, bicycle, 2, binomial, 2 terms. So I take one of my binomials, just like with the box method. I split them up between the boxes. 5 plus 2i I'm putting down here. It doesn't matter which one you put where. It really doesn't matter. Because we're just multiplying them together anyway. So when I do so with this, positive I times 5, positive 5i. 10 times positive 2i, positive 20i. Positive 2i times I. This box right here, I'll tell you right away, is going to always be the most complex box. No pun intended. So we'll take positive 2i. We are multiplying it by another I. So how can I rewrite that? Good. So we take that and it's now 2i squared. And that's not the end of it because remember our 4 main answers. I squared is -1. Isaac?
Always -2.
Good, because you know that I squared is -1.
Yes.
You multiply it by 2, you get -2. Okay, that box is always going to have more information in it, but we can do it one step at a time. Remember, we're always trying to simplify so that we can count on those 4 answers. All right, now I carefully have to bring these terms out. We have a positive 50, positive 5i, we have a positive 20i, and we have a -2. What can I combine with my 50 over here?
-2.
Good, so we have 50 minus 2, we have 48. Then on the inside here we have positive 5i and 20i. Positive 25i. That's going to be my answer. Let's go over and now see, how did we get there? We simplified, if possible. So if I did have an I to the 17, I would simplify that first. In this case, we just had I to the first, so we couldn't simplify it. So step 1 didn't count this, wasn't used in this example. But we did the box method. You could do FOIL or the box method. If you show your work using each or either, that's fine. So we did all that. We then got our terms out here. We combined like terms. And then write it in standard complex number form. Remember this. The real number comes first, and then the imaginary. The imaginary has the imaginary number in it. Okay. So I think you've seen this enough now. Why did I put the 48 out in front? Because that's the real component of that complex number. Good? Okay. Who needs to see another example like that?
I have. Can you do the box method again?
Sure. All right, I'm going to go ahead and fit it right here. Okay, let's go with, I'll make this slightly more complicated. 2 plus 5i times, let's go, 10 minus 6i. So I just put in a negative in there. That'll just be something we have to deal with. So I know if I use my box method, I'm going to make it 2 by 2 because we have a binomial, 2 terms. So I'm going to say 2 plus 5i on that side, 10, and negative 6i on the other. Okay, now it's just multiplying. Remember, the box method, the same as FOIL, is all about multiplication. Now remember, I'm going to jot it out real nice here. So we have 2 times 10, 20. I have 10 times 5i plus 50i. Okay. See, we're just kind of connecting them this way. I have 2 times a negative 6i. Very good. And then finally, negative 6i and positive 5i. This is where, remember that last box? This is where we're going to have a little bit more work to do. So first I'm just going to write them out. Let me work this out. I'm going to write this out. 5 times a negative 6, negative 30. And then we have I squared. We know that I squared from our definitions right here. I squared is just negative 1. So I'm going to put in my negative 1. Altogether, this ends up negative times a negative,
30.
positive. Okay. So now I take those terms really carefully, making sure all the positive or negatives are accounted for. We have 20 plus 50i minus 12i plus 30. If you go if you go to these terms and you pull out, you're going to say, I'd like to just pull out this positive 20 and this positive 30 first because those are the real. That's fine. That's a little shortcut if you want to make it easier. But here, if I had just written it like this, as I did, I'm just going to combine my reals, 30 and 20. Combine my imaginaries, 50 minus 12 is 30. Thank you. 50 plus 38i. Okay, how's that now? Good. So the hardest part is, again, it's this box. Fourth box. It's not so hard though. It's not so bad. It may be hard, but we can work through it one step at a time. Each individual step isn't super tricky. We just got to remember that process. All right. Let's go ahead and take a look at this chart in the middle. This is, and if you didn't quite get the box method, we have to do it once more for our last problem here. So don't worry about that. Don't look at this yet. Don't worry. Here we're talking about the complex conjugate. So when we have a complex number, we have a real number and an imaginary number. But with our complex conjugate, we're going to end up with a real answer because a complex conjugate are two complex numbers that multiply to give a wholly real answer. Okay. And this is great. So we start with this complex number, 5 plus I. The complex conjugate is 5 minus I. What is the difference between my first expression and the second expression? What changes? What changes? Good. It's that easy. All that changes with the complex conjugate, you look at the operation going on between the two terms. Here the operation is addition. So over here the operation for the complex conjugate is going to be subtraction. Whatever's going on between the real and the imaginary switches to the inverse of it. So right here, 10 plus 5i, I know that nothing's going to change with my two real and imaginary components. The only thing that's going to change is good. The operation was positive. The opposite inverse here is negative. or just the inverse is negative. All right. This is something that we are going to use later on. They introduce it in this chapter, so at this point it's pretty straightforward on what we have to do. There's one problem on the quiz that talks about this. So on the quiz, if you're given 1 minus 10i, I know that 1 and 10i are those terms that are going to stay. The operation is subtraction, so we end up with addition. Okay. So how does this apply? Let's see if this works. Here's the complex number that's given, 2 plus 2i. The complex conjugate is 2 minus 2i. We know that if we multiply these together, we're going to end up with a wholly real answer. So I look down here, all I have to do is multiply these and see if that is in fact true. I set up my box, 2 minus 2i on this side, 2 plus 2i on this side. Really important too that also put that sign connected to that term, because that is one area that could mess you up if you don't have that over there. You might leave it out. You don't want to leave out a negative because that would change it. All right, 2 times 2, 4. 2 times 2i, 4i. 2 times negative 2i, negative 4i. 2i times negative 2i, negative 4. And I'm going to step back one sec because it was negative 4i squared, which allowed me to do what? What's I squared? Negative 1. And that's how we ended up with positive 4 for this. I rewrite my terms, 4 minus 4i plus 4i plus 4. What happens to my middle imaginary terms? Negative 4i, positive 4i. They're going to cancel out. What's left over is 8. So I know that this was a complex conjugate because when we multiply them, we got a wholly real number. There's no imaginary component. Okay. There are some things that are just almost purely kind of definition concepts, and this is at this point just a definition concept. There's nothing more at this point we're going to do with this. Okay, so kind of log it away as such. Don't look to do anything else. We know this is a complex conjugate because when we multiply it with what we're given, we get a wholly real number. All right, I'll move this over. Good? Let's see how we are with time. 12. Okay, this is 3. All right, this is something we've talked about before. The impedance is talking about the resistance within a circuit. The resistance at different kinds of metal, or a transistor or a resistor would put on that circuit. And this is kind of the more refined definition here. I want to focus on the shortcut, but the refined definition is, so I'm given an impedance 1 and an impedance 2 as a complex number. I'm going to take those numbers and put in the denominator of fractions and add them together. What happens when you do that? You have to find the common denominator. You have to adjust the numerator to accommodate how you change that. So our shortcut is really what we end up doing. We take that complex number, impedance 1, we add it to impedance 2 on the top, in the numerator. We're then going back here, and on the bottom we're multiplying those values together. So on the top we add them together, on the bottom we multiply them together. This looks complex, but really we've done this. We did this yesterday. We're doing this today. So this topic only is combining two things together. So say I'm given these two values. I'm given that there's these two circuits. Very important that they're in parallel. So before we've only done them when they're paired, but here they're in parallel, which is a different configuration requiring this formula, this approach. All right, we're given that the impedance of the first circuit is 2 plus 5i. The second circuit is 3 minus i. So look what I did here. I know that I'm adding them together on the top. I added them together on the top. I multiplied them together on the bottom. And from there, we're going to be able to get right to our answer. Oh.